Okay, let's get started with some definitions and a rationale for doing statistics in the first place. These terms are fairly easy to understand, but it's essential that you get them right. Unlike what you may think, statistics is actually not required because the faculty wants to torture you. It fits into a sequence of courses focused on research methodology. In this slide, I've laid out an overview of the research process. Your other research-oriented courses are going to cover formulating a research question, developing a research hypothesis, operationalizing variables, and data collection and report writing. In this class, we'll be spending most of our time here analyzing data, though in this presentation, we'll also focus a little bit over here on variables. So much of what social scientists do is focused on prediction. The idea here is that prediction is believed to lead to understanding of the relationships that characterize what people do. Let's take a look at two well-known relationships, one from sociology and the other from psychology. Durkheim's famous study of suicide showed that countries in Europe that lacked social cohesion, mostly due to a decline in traditional ways of living, had higher suicide rates. He found, in other words, a relationship between these two variables, social cohesion and suicide, which enabled him to predict suicide rates. Albert Bandura was interested in social learning. His work explored how people learn, and he found that if children watched someone perform a task, they were more able to learn it, as opposed to, say, just telling the children how to perform the task. Again, a relationship between two variables, modeling and learning. In this class, we don't get too far into how these variables, social cohesion, suicide, modeling, or learning, are measured. Our focus assumes that the measurement strategy is legitimate, that it's correct. Instead, we'll be focused on analysis. So what then is a variable? That's our next topic. A variable is simply a property or a characteristic that you're interested in studying. The technical term for this idea, whatever it is you're interested in studying, is unit of analysis. The best way to explain this is with some examples. Here are some properties of people. Everyone has an income. It might be zero, of course, but that's still their income. Everyone has a race, an education, even an attitude about something, say, like gay marriage. And that's even if they haven't yet been asked for their attitude or thought very much about gay marriage. You probably notice here that some of these properties are intrinsic. That is, people are born with them and they don't change over time. Examples would be race, gender, probably sexual orientation, although that can be somewhat fluid. Others, like their attitudes, can change based on their experiences, where they live, how they were raised, etc. People are probably the most common unit of analysis in the behavioral sciences, but they are by no means the only thing that behavioral scientists measure. Let's take a look, for example, here at families. Families can be units of analysis as well. They have properties also. Properties that can vary from family to family, or even within the same family over time. The number of vehicles, for example. The Jones family might have 2 cars, and the Murphy family might have 3 cars. Next year, the Murphys might get rid of 1 car. Maybe Mr. Murphy had a cut in his income, or maybe his teenage son moved out and took one of the cars. Maybe he lives in a high crime area, and one of those cars was stolen. So these properties, these variables, can vary across families and over time. Here's another example of a unit of analysis, a school. Schools can have properties or characteristics as well. Consider this variable over here, number of disciplinary actions reported. This can change over time. Maybe a new program is introduced to address discipline problems. If it's successful, then next semester there ought to be fewer such problems. We'll be looking at a lot of questions like these in this course. You have to understand here that all of these variables can change for a number of reasons. Let's take a look at this example of disciplinary actions. A new program might bring out change, but there's always some background variation, some random variation as well. If you've taken the SAT or an exam like it several times, your score probably varies a little bit each time, even if you don't study that much over subsequent takings of the test. A question we'll be asking again and again in this course is the change we're observing here, is the difference between what we expect and what we observe sufficiently large in order to be meaningful, or was it just within the normal variation that we might accept? So, this kind of brings us back to this question of prediction. If we're predicting outcomes using variables, we need two types of variables: dependent variables and independent variables. Dependent variables are the variables we're trying to predict, what it is we're trying to explain. Independent variables are the variables that we think cause the changes in the dependent variable. A few examples maybe provide the best way to understand this. Here are some things that a social or behavioral researcher might want to study. Take a moment to think about what might drive differences in attitudes towards gay marriage, in support for government-provided health insurance, or for capital punishment. What things might cause changes or differences in attitudes about these three things? Here's what I came up with. You probably come up with some others. For attitudes towards gay marriage, maybe it's religion, maybe education, maybe frequency of church attendance, maybe whether the person lives in a rural or an urban area, which might have something to do with their level of exposure or acquaintance with individuals who are gay. You may have come up with some other things. Support for government health insurance. We might look at age, we might look at income, we might look at satisfaction with current insurance or health status. We might look, in some kinds of analyses, we might look at a couple of these things. And then finally, support for capital punishment. Certainly there's some research that says that this depends in part on race and gender, perhaps with experience with victimization, perhaps with attitudes towards race, and perhaps also with attitudes towards the police. It's important to remember here that there's no master list of dependent and independent variables. For example, in this case, support for government health insurance might depend upon income, right? But income is a variable that might serve as a dependent variable in another study, say a study about the impact of union membership on income.
Of course, some variables can never be dependent variables. Things like gender or race, country of origin. These are all intrinsic characteristics, so thinking about them as the outcome of something else doesn't really make any sense. The key thing to remember here is that the dependent variable in an analysis represents the thing we're trying to explain. Someone's attitude towards gun control, or the number of disciplinary actions in a school. Independent variables are the variables that do the explaining. Let's move on now to talk about another important topic, levels of measurement. Levels of measurement are important because they are one of the things that determine the kind of statistical analyses we can do.
The level of measurement of a variable has to do with the kind of information captured by that variable. Levels of measurement are about whether a variable represents a quantity, and if so, what kind of a quantity? Yes, there are actually several different kinds of quantities. There are three levels of measurement that we'll be concerned with in this class. Nominal, ordinal, nominal, ordinal, and interval ratio variables. Some texts make a distinction between interval and ratio variables, but for the kind of analyses that we'll be doing here, this distinction really isn't very important. All right, so nominal variables have no element of quantity or amount. Race, gender, religion, etc. aren't amounts, they're simply categories, right? Catholic, for example, doesn't represent more of anything compared to, say, Jewish. Ordinal variables do have some notion of quantity. For example, someone who graduated from high school has more schooling than someone who only made it through elementary school.
Attitudes are usually measured on an ordinal scale as well. If you've ever taken a survey of some sort, you probably remember a question that asks you how much you agree with a statement. Say a statement about gun control. I might agree with such a statement more than you do. Because there's an element of more or less agreement, we would say that such an attitude is being measured on an ordinal scale. The thing is, though, that with ordinal variables, we don't know in a mathematical sense how much more strongly I feel or you feel about something. If you say you strongly agree with a statement about gun control, and I say I somewhat agree with the same statement, is the difference between our levels of agreement the same as the difference between, say, someone who indicates that they strongly disagree with the statement and someone who only somewhat disagrees with it? Interval ratio measures are measures where we're dealing with real numbers, things like income or age or number of children, things that we can do actual arithmetic with. For example, I can say that I have twice as many children as you do, or that teachers in New York City earn 20% more than teachers in Atlanta. We can't make these kinds of more precise statements with ordinal level data, and that's a key difference.
Okay, so as I said, let's look a bit more closely at the difference between ordinal and interval ratio measures. Here are two survey questions that ask about a respondent's age. One measures income on an ordinal scale, the other on an interval ratio scale. We know that someone choosing the third age category here, 31 to 40 years old, that person might be 32, they might be 39, they might be 35. We can't specify how much older that person is because we can't subtract his age or her age from someone in this category, the 20 to 30-year-old category. On the other hand, someone answering the what is your age question at the right is providing us with a number that we can add and subtract. We can specify, for example, how much older that person is compared to the average of everyone in the sample, or the average in some other sample, or some average in a whole population. Here's another example.
This question reads, to what extent do you agree that race relations are a serious problem in the United States? Clearly, if I strongly agree, and you only somewhat agree, then I agree more than you do. But how much more is the question? In a mathematical sense, we don't know, and this in turn limits the kinds of statistical analyses that we can do with variables that are measured on an ordinal scale.
So that's pretty much it. I hope you'll agree that these concepts are not too difficult to understand, and you can practice identifying dependent and independent variables and levels of measurement in the homework.